Hey everyone, Jeremy here. Welcome back to the Towards Data Science podcast. And today's episode is going to be a little bit special because we're talking to Melanie Mitchell, who, apart from being the Davis Professor of Complexity at the Santa Fe Institute and a Professor of Computer Science at Portland State University, is also a prominent author in the AI safety space and a prominent skeptic of a lot of the AI existential risk arguments that we've explored on the podcast here. As many of you will know, especially if you're longtime listeners of the podcast, I myself am actually quite concerned about existential risk from advanced AI systems, which is precisely why I found this conversation so useful and fruitful. It's always great to talk to people who disagree with you, especially if they're as thoughtful as Melanie is. Finally, if you're curious to dig deeper into Melanie's views on AI existential risk after listening to this podcast, I do recommend her 2019 book, Artificial Intelligence, A Guide to Thinking Humans, and the podcast that she did at the Monk Debates with Stuart Russell. So with that out of the way, I'll step aside and let you enjoy the conversation. All right. Well, Melanie, thanks so much for joining me for the podcast.
Oh, I'm thrilled to be here. Thanks for inviting me.
I'm really excited to have you here. Your 2019 book, Artificial Intelligence, A Guide for Thinking Humans, offers a perspective I think that's quite different from many of those we've had on the podcast so far. I think you're really one of the most interesting proponents of the sort of skeptical side of the AI existential risk argument, which is why I'm so excited to have you here today. Now, AI safety is a big topic. I think there are a lot of places we could start, but I'd like to begin with your assessment of sort of where we're at today in AI. Like what are the things that AI can do today that maybe you find impressive, but also what are some of the blind spots that we have as AI capabilities are concerned?
So AI has obviously excelled in a lot of relatively narrow domains, speech recognition, machine translation. And by narrow, I mean sort of narrow as compared to the generality of human intelligence, right? So each of these systems is able to do a particular task and it can do it very well. But it's the challenging thing is getting machines that are able to take their knowledge on one kind of task and adapt it to another kind of task, or to be able to deal with new situations that are sort of outside of the distribution of their training data and so on. So these are well-known challenges for the field, and they do produce some what people call brittleness, meaning that the machines that are trained to do certain tasks can have unpredictable failures, very unhuman-like failures. And this can lead to risks, it can lead to risks like we see in, self-driving cars, for example, that can make errors that can see a picture of a person on the back of a bus and think that it's an actual pedestrian, or that think that a sideways semi-truck is actually just the horizon, or whatever the different errors are, errors that humans wouldn't make. Of course, humans make different kinds of errors when driving. But this just gives you an example of the kinds of risks that, that make it hard for us to trust these AI systems with our lives. Yeah. And then there's also the vulnerability to adversarial attacks that we see that makes using these systems in any kind of, life critical situation kind of difficult right now, because these systems do have vulnerability.
Would you be more impressed with AI technology if its failure modes were more human-like?
I would be more impressed if its failure modes were more human-like, because then I would have a better idea of when to trust it and, when not to trust it. That would make it easier to sort of figure out how to use it safely. Humans have their own failure modes and biases and so on, but we've kind of developed the infrastructure, if you will, to deal with some of that. And now we're taking AI systems and we're trying to rejigger our infrastructures to deal with their kinds of failure modes. So it would be better if the machines were able to better be like humans, obviously, to.
Yeah, it's interesting what that all implies about the way that these AI systems are reasoning about the world, if that's the appropriate word, the fact that those failure modes are so different sort of seems to hint that there's something else going on. Maybe that'll be actually a good foundation for the next question I'm going to ask here, which is about the AI existential risk argument. So I mentioned earlier, I mean, you really are a well-known AI existential risk skeptic, though you certainly have highlighted a number of risks with the technology. What's your take on the arguments for existential risk? In your model of the world, why are people concerned about existential risk? And then what is it that those people are missing?
So my understanding of some of the people who are worried about existential risk is that, here's sort of my version of their argument. We don't know how soon we're going to get human level AI or super intelligent AI. And there's some worries that such a system could make decisions that affect the existence of the human race. There's the existential risk part. Because they don't share our values or have our kind of common sense abilities. So therefore, we should start preparing for that now. That's sort of my summary of maybe Stuart Russell's book, Human Compatible, some of the work by Bostrom and other sort of famous existential risk people.
Superficially, to me, that sounds bang on in terms of what keeps me up at night, so to speak, with this area. You've highlighted a lot of really interesting, I think, areas where people who think in this way tend to be a little bit less aware, or considerations they don't weight as heavily as maybe they should. I'd love to get your thoughts on that aspect.
I was particularly struck by the kinds of examples in the writings of some of these existential risk, I'm not sure what to call them, proponents, warriors. They had examples like, here's a scenario, like we have a super intelligent machine and we entrust it with solving the problem of climate change. And it decides that the best way to solve the problem of carbon emissions is to kill all the humans. So to me, it's like, that seems crazy. That's just like saying that you could have a quote unquote super intelligent machine, but it wouldn't have any common sense. It wouldn't have any sense that human life is valuable to humans, and to make those kinds of things orthogonal, to me, misunderstands sort of what intelligence is all about. So that's really, I feel that super intelligence itself, that notion, is very ill-defined. What people mean by that, and whether it's even possible to have something that is, what people have said, much, much smarter than any human, because intelligence is so complex, it's so multidimensional, the dimensions of it are so entangled, I believe, that I don't think you can separate these things. So Bostrom, for example, had what he called an orthogonality principle, which was that intelligence is orthogonal to objectives and values. And I just don't believe that at all.
One of the things I was wondering about with respect to the example you cited with Stuart Russell and the climate change AI that then destroys everything, the way I interpreted his claim was not necessarily that the mistake made by the AI would be that obvious, but more that systems are incredibly complicated. In general, we'll want to develop AIs that can solve problems in ways that we would not have thought of. And the risk is that those solutions are sort of dangerously creative, that we may kind of specify an objective for the AI to accomplish, but sort of like King Midas, everything he touches turns to gold. That's what he wanted, but then he ends up turning his whole family to gold and so on. You do end up with this situation where, for reasons that are subtle, not necessarily as obvious as like to reduce CO2 emissions, we'll just kill everyone, but the AI comes up with a convoluted solution, and that in the space of possible ways to solve a problem, the argument, I guess, is that the vast majority of points in that space lead actually to catastrophes as far as humans are concerned when you optimize with respect to like one metric. I'd love to get your thoughts on that, because I'm sure you have some.
I didn't see that kind of subtlety in Russell's arguments, but I think that is a good counter argument to what I'm saying. And I think we do see that kind of thing not only with machines, but with humans. That kind of, for example, the phenomenon of Bitcoin. It was created to decentralize currency and to enhance freedom and privacy and all of that. But there was a side effect that I don't think people really understood until much later, which was the environmental impact of all this Bitcoin mining that goes on. And that could be, contributing to an existential threat. And so the people who developed Bitcoin, obviously they're super brilliant people. I don't know if they foresaw that. So you could say, yeah, a machine could do something like that. It could come up with a solution with these kinds of unintended negative side effects. But a machine can do that today. That we see that today happening, with things like the stock market flash crash and things when we give machines certain objectives that negative things can happen. My objection was more just to the idea of a super intelligence.
Okay.
And what that means. Sure, we should have more insight into how machines are operating and how the objectives we give them can have different kinds of effects. But I don't think that the argument is that there's going to be some quote unquote super intelligent AI and we say, oh, let's just unleash this on the world and let it have the power to destroy everything. I just don't see that as an immediate near-term threat to society. It's more like using these machines that are non-intelligent, that are not intelligent at all, and allowing them to have certain kinds of autonomy. That's much more of a threat.
Right, and that's really, I think, where there's an interesting kind of differentiation between the two risk classes that you've been really good at kind of distinguishing between those two issues, which I think is also really healthy because it's so easy to confuse the risk from self-driving cars with the more existential risks that people talk about in this space. When it comes to the existential risk piece, like the argument I think I've tended to see, it does, you're right, come from a place of inherent, I don't want to say techno-optimism, but at least the belief that superintelligence is possible is definitely like a core assumption. What are the things that cause you to think that superintelligence is, let's say, highly improbable? Would that be a fair characterization?
Well, I would say it's more ill-defined. I don't think we understand very much about intelligence scientifically. It's a word that means many things.
Yeah.
And there's this sort of view in the computer science world that we can develop AI as kind of this brain in a vat, if you will, that's sort of isolated from everything and getting some, sensory input and then doing some output. And there's no notion of kind of development like the way we have children learning and social interaction, being part of a culture, growing up as part of a culture. And I don't think you can easily separate those issues when you're talking about intelligence. In some sense, all intelligence, at least the kind that we're interested in having AI mimic, is socially grounded. We humans, the reasons for our big brains most likely is to deal with a complex social environment. And that is something that AI people think can kind of be separated from this sort of notion of more pure intelligence. And it should be said, people say, oh, we're going to have these AI systems. They're going to be super intelligent, but they're not going to have any of our cognitive biases. They're not going to have any of our faults like, getting tired and sleeping and getting, getting emotional or, that kind of thing. And the idea that there's this separability among all these aspects of intelligence is something that I'm skeptical of. Maybe I'm wrong, but I feel like we don't really understand enough about intelligence to assume that there's some kind of pure notion of intelligence that could be imbued or have machines learn somehow that is separated from all the other aspects.
It sounds like you have a strong suspicion then that there's some level of socialization required to get to general intelligence. Is that fair to say?
That's my suspicion, yeah.
Okay.
Absolutely. And general intelligence, again, it's one of those terms that it's hard to define because we
Right.
don't really know what we mean. And
Yeah.
some
Which
people say there is no such thing. Some people argue there is no general intelligence. Humans are, have a specific kind of intelligence, or they have certain kinds of skills, and there's no kind of notion of generality. Now, I don't agree with that necessarily, but I think the term itself really needs to be fleshed out.
on the AI risks or like what should we do side of things, I guess then it becomes a game of probabilities to some degree. So there's like, what probability do we assign to the thesis that intelligence needs to be socialized? What probability do we assign to the contrary thesis that says like, yeah, actually we can build whatever with whatever? And then how should we act in light of, I guess, something like, the expected returns? If there's a 1% chance of like AI apocalypse, then well, presumably that's worth acting on, and the probabilities matter here. So for the sake of talking probabilities, what's your gut feeling in terms of whether superintelligence is possible without socialization?
It's hard to speculate on super intelligence when I'm not even sure what it means. But
Right.
I think Bostrom had a definition, which I can't quote exactly, but it's something like, a system that's able to do any task that a human can do and excel, do it faster, better, more accurately, and so on. So I believe that without living in kind of the human social cultural world, without being kind of growing up in it, I would wager that it's impossible to get to that kind of human intelligence.
Do you think that sociopaths would be a good counterpoint to this? Not to go straight to Hitler on this one, but Adolf Hitler, presumably very bright guy, unfortunately, but obviously had various he did not relate to human beings, let's say, in the way that one should.
I don't think that's really a valid point, because even a human sociopath, if you will, and I'm certainly not an expert on this, but it's not like they're devoid of emotions. It's not like they're devoid of sociality. It's not like they didn't grow up and develop the way that other humans grow up and develop. There's just some kind of deficit there. I don't know exactly what it is, but people like that can function very well in society and can be fairly intelligent, but they can also cause great damage, certainly. But I think that's not a great analogy with a machine. Machines, at least right now, they have nothing. They're just far away from any biological intelligence.
Yeah, I guess I'm just wondering about the decoupling between the sort of
Yeah.
socialization and almost like a caring. Is it caring for others? Would that be like the main thing that you'd consider to be like a critical part of this general intelligence? Or?
It's more like caring for others, but also understanding a kind of theory of mind of others, and understanding their goals, understanding their motivations, understanding why, being able to predict them, to model them. That's something that I think a lot of people have argued that's why we humans became so quote unquote intelligent. It's in order to be able to successfully model and predict what other people in our group are doing, or why they're doing what they're doing. That's something, that's certainly lacking in machines. And the thing about machines is that we want them to do things that require interaction with us, like driving or cleaning our houses, or terrible example, but very, very timely, fighting our wars. There's been a lot of talk about autonomous, war fighters and all of that kind of thing. And fundamentally involves interacting with people and understanding other people. So that's, I think, something that people are trying to get AI systems to do now, but it's very difficult and no one really knows how to do it well.
Yeah, it definitely seems like in a lot of these catastrophic scenarios where you have the kind of AI in the box, and then it sort of finds a way to break out, the sort of classic breakout scenario in AI safety. It does seem that those require some kind of theory of mind, as you say, because like, how are you going to manipulate? I think one of the classic examples, maybe Max Tegmark might have used this one, but like the janitor who walks by and then gets roped into like helping the thing break out. You need a theory of mind for the janitor to convince them to do X, Y, and Z, and so on. To the extent that an AI system could do that, like if an AI system could, let's say, predict the behavior of the, I don't even, this is also fuzzy, but the median human being or something like that in some meaningful context. Would that move the needle for you? If you saw that, you'd be like, okay, I think that can be done then, divorced from the sort of socialization aspect?
Well, we already have systems that can do some kind of prediction of us, right?
Right.
I mean, frighteningly, like our
Yeah.
social media platforms
Yeah.
predict us all too well. But I think they do it kind of in this associational way. They don't have sort of rich models of human behavior. I don't know if that would move the needle or not. I think that it's essential for intelligence. It's essential for like being and acting intelligently in the world. So I think we have to be able to get our systems to do that. We have to get our self-driving cars to be able to predict what a human pedestrian is going to do, or why they're doing what they do. Would I find that more kind of risky? Well, I guess as the systems get more and more intelligent, we have to think about sort of what they can do autonomously and how much we can trust them. But I guess my point was that in order to get systems to be able to do that, I believe that they would have to, in some sense, grow up like our children grow up in a culture, in a society. And in doing that, they would absorb their own values and their own objectives. I don't think that you can have this sort of super intelligent yet strangely passive, programmable system that, the idea there, like Stuart Russell's idea that we're going to have a super intelligent system, but we have to have it absorb, learn our values. Well, there's a way to do that, like with children, right? That's called raising children. But raising children involves having an agent with the right kind of architecture and the right kind of learning environment, and allowing them autonomy. They're not passive; they're active, and they're not just waiting to imitate us. They have their own autonomy.
And to the extent, I guess, that you have, let's say, super intelligent systems that are being raised, and I'm using a lot of air quotes here because I don't know what I'm talking about. But anyway, which is very much to your point. To the extent that we have systems like that are being raised in this way, I guess we do see sort of like misbehavior. Like, again, Adolf Hitler had parents and Pol Pot had parents. Could you see an existential risk arising from a super intelligent system that meets all those criteria, but is just like, let's say, raised improperly, which might be another word for aligned improperly?
It's possible. I just see it as a very distant kind of risk. I certainly don't think that this kind of quote unquote existential risk is impossible. And it's true with any technology, right? But I just think there's a lot of near-term risks that we should be focusing on, as opposed to this what I think is a very longer-term risk that we don't even quite know how to frame the problem exactly.
Yeah, and I think one thing that might actually straddle the line, I do want to get into your thoughts on like near-term risks that we really should be looking at. I suspect we're going to be agreeing on an awful lot of stuff there, but the thing for me that straddles the line between near and far, and that I think has been it's been interesting to see how people respond to it, is GPT-3, OpenAI's large language model. Obviously, since then, Google's come out with a bigger one and so on, but this idea that scaling models seems to lead to a little bit more generality, a little bit more sort of flexibility, at least in terms of the use cases. Whether or not the use case, I wouldn't trust GPT-3 to like, I don't know, tell a doctor what steps to perform a surgery in, but you can imagine some, especially GPT-4 as these systems improve. To some people, they've seen this as like, okay, it looks like we're on the way to generality just by scaling existing systems and maybe adding some spices and salt in there for extra flavor. But do you see that happening? Is that a convincing thing? Were you surprised by GPT-3 in that way or not?
I was not surprised by GPT-3 in that way. I was surprised by it in some ways, because, I think GPT-3 is, it's a language model. It doesn't have any rich internal models of the world. It doesn't know how the world works. You can see that by questioning it about the world. And lots of people have published papers about that kind of thing, that it can just spout complete and total nonsense and things that are just, factually wrong about the world that no child would ever say. I was surprised at how good it is at generating seemingly coherent text. And that was, but it, I think it's doing it by statistical association, just like, say, a speech recognition program on your phone has learned a lot of statistical associations between sounds and words. And I'm surprised at how well those can do just based on that kind of approach. So I am always surprised by these kind of how this scaling these models to very large data sets and very large networks can improve them. I don't believe that if you continue scaling GPT-3 so that it memorizes all of human language, whatever, that it's going to be a general intelligence. I don't think that that's sufficient. Maybe it can sound very convincing, but it's not going to be able to do the kinds of things that we humans can do. It's not going to be able to communicate in the kind of ways that we humans communicate. So it remains to be seen, but I don't believe that's going to happen.
This is its own interesting question. Like, what is the bar for us to say, okay, there's actual reasoning going on here? Is it sufficient to show some examples where GPT-3 seems to extrapolate beyond its training set, seems to do things with number addition with like three-digit numbers, stuff like that, even though it fails with more digits? There are some cases where it seems pretty clear that it hasn't seen certain combinations of things and it still gets those right. But then there are, as you say, there are these glaring counterexamples where you'll give it, two facts in a row and then it'll fail to kind of connect the two in different ways. So do you think that this issue of like necessity versus sufficiency is an important thing that we should be talking about? Is it enough for these models to show some reasoning ability, or do they need to be more robust before we declare them to be doing something interesting?
I guess it depends what your goal is. If your goal is to build AI systems that will turn into products, then perhaps it's sufficient, for certain things. It's maybe not as reliable as you'd like it to be, but it's reliable a lot of the time. And if there's a human in the loop, that's great. But if your goal is to understand intelligence or to get to general intelligence, some kind, it's not sufficient. It has to be more robust. Now, this brings up a question of how do we tell? How do we know when something is generally intelligent? And most of my colleagues in AI absolutely hate the Turing test. But I'm actually more of a fan of it than most people I know.
Oh, cool. Okay.
Yeah.
I'd love to hear yeah.
The way it's been carried out so far, I think has been very flawed. It's easy to fool people. It's easy to fool judges. We've seen that for decades in AI, going back to ELIZA, which fooled a lot of people.
And just for people who might not have like dug into the Turing test, I think most people have like a vague idea of how it works, but could you sort of lay out like what the standard, maybe ELIZA version of the Turing test was?
Right. So Turing himself wrote a paper about this, proposing that you have a machine and a human that are sort of competing against each other to convince a judge that they are human. Okay. And they can only communicate using language, and you can't see the either, because you don't want to have what they look like influence you. So the judge, Turing, proposed that in his paper he proposed that like a 5-minute conversation might be revealing. Well, it turns out a 5-minute conversation can easily be created by a chat bot and a not necessarily expert judge, and fool the judge. ELIZA was a simulated psychoanalyst that was developed in the 1970s, I think, using just incredibly simple little templates and replies. It was one of the first chat bots. And it actually, people talked to it and they thought that it was understanding them because people are so, prone to anthropomorphizing and to giving sort of agency to something they're communicating with. So I don't think that kind of Turing test tells us very much except about the gullibility of humans. Mm-hmm. But I do think that there are versions of the Turing test that we might be able to construct that would really tell you a lot more. Now, there's a famous long bet between Ray Kurzweil and Mitchell Kapoor. So whether an AI system will be able to pass the Turing test by 2029. And they each bet $20,000 or something like that. And this was, many years ago, they had this bet. But they set out this incredibly stringent Turing test with very expert judges, and it lasts for hours, and you can probe it in many different ways. And reading that whole description of their Turing test, I thought, if something passed that test, I would be very surprised, but also it would move the needle on my belief about sort of this system having some general intelligence.
The fact that you're thinking in terms of like, what are some of the things that could convince me otherwise? I mean, this is something that I'd love to see more of in this space generally, because it's so often it seems like people's aesthetic preferences are the dominating factor. I'm a person who tends to worry about the future. So of course I would have these concerns about existential risk from AGI. I'd be more receptive to that kind of argument. It's just really cool to see it there. And the GPT-3 angle, I mean, that seems to me to be an interesting tie into some of your more current concerns. So, to the extent that we are worried about existential risk from AI, that does pull resources away from current concerns. And I think it's important to highlight that trade-off. Would you mind laying out maybe the most salient concerns, the most serious concerns you have about current use of the technology?
Yeah, I mean, GPT-3 is a good starting point because this ability to create sort of fake media, like fake text or images, videos, audio, whatever, it's getting better and better at a very alarming rate. And we've seen these deep fakes improve enormously. And it's easy to fool people. Yeah. So that can be I feel like that's going to be a really difficult issue for the spread of disinformation, propaganda, so on, very, very shortly. Maybe it's already starting to be. So that I think is an immediate risk. And the machines that create these fake media are not generally intelligent. They're not super intelligences. They're just our, everyday deep neural networks, what have you. So I think that's a big problem. There's also a big problem of racial and gender bias and other kinds of bias in these systems that, a whole lot of people are trying to figure out what to do about now. And there's also the problem of us sort of being too trusting and too optimistic, I think, about how reliable these systems are going to be. There was just recently a big report out from a committee that was looking into like autonomous weapons. And it included Eric Schmidt, former CEO of Google, and other technologists who really felt like, we are almost there. We're almost at the point where we can deploy autonomous weapons, and we're going to figure out how to prove that they're reliable and all of that. And I feel like that's this kind of over techno optimism might lead us to some real problems. So those are more the immediate risks that I see. There's, other kinds of civil rights issues with privacy and surveillance, and just a lot of things that are going on, and dealing with like figuring out international regulations on these technologies is a big problem.
Actually, this brings to mind another, I guess, variant almost on the existential risk argument that maybe is one that you'd probably find more convincing or more interesting, let's say. And that is just the idea that, as this technology improves, the destructive footprint of malicious actors starts to increase, and our ability to do horrible things to ourselves as a species in much the same way that nuclear weapons just gave us another way to kill each other. Maybe this eventually culminates in something really disastrous. Is that something you consider plausible?
Absolutely. Yeah. I think there's the vulnerability to malicious actors. We've seen that time and time again, like cybersecurity, and with deploying all these AI systems and all of our devices and our cars and our electrical grid and everything, it's just opening us up to a lot of vulnerability.
And how do you think about the game theory? You alluded to regulation, and like I think yeah, I'm a big fan of the idea that we are going to have to regulate somehow the space. It's I guess it's a complex question of how to do that, but it's in the context as well of this awful game theoretic dilemma too, where you have the United States, you have China, various other global powers, all vying for dominance, all developing this technology. One of them can, of course, step back and say, we will not develop autonomous weapons, but then, of course, why trust other people? This is probably a question best posed to like an AI policy wonk, but just because you've done so much thinking in this space, do you have any kind of intuitions about where there might be some traction to be had on addressing that issue?
Yeah, that's a really difficult issue. And as you say, it's not my area of expertise, but I think that, like nuclear weapons, you're going to have to use, we're going to have treaties and diplomacy and international pressure. And, it to me, it's kind of analogous to the situation right now in like bioengineering, genetic engineering, which is another source of possible existential risk, if you will. And we're struggling with how to regulate that, how to regulate it internationally using the UN and other international bodies. I think the same thing is going to happen with AI technology, but it's a very difficult problem.
And is there anything that technologists can do, like researchers, for example, focusing their research efforts in specific directions that you think might help? Can AI be part of the solution as well as the problem?
Yes, I think there's a lot of things people could do, ways to make AI more robust, more trustworthy, and that's multidimensional, but more transparent. One of the problems is that these AI systems are black boxes. It's hard to figure out what they're doing, how to sort of certify them, somebody proposed having an FDA for algorithms. How would you certify that an algorithm is safe? Mm-hmm. Like the way you do with like a new drug or something like that. It's going to involve a lot of breakthroughs that will be needed to do that kind of thing. But this is something that computer science has been working on for a very long time, how to sort of do verification of algorithms and kind of prove that they're doing what they're supposed to be doing. And, there's just a lot of research that can be done in this area.
In your book too, I think you wrote about GDPR and sort of how the right to explanation plays into all this as well. I'd love to get your take on that, because I think it's, some people see the GDPR thing as overbearing, but other people see it as necessary. And then it seems like you've got a pretty nuanced take about what an explanation is, and sort of inviting a lot of philosophical questions around that.
Yeah, well, it's a difficult question because GDPR is the European Union's law, which part of which says if an algorithm is going to affect your life, like decide if you're going to get a loan or if you can get approved for housing or if you're going to go to prison or whatever, it needs to be able to explain its reasoning. So if you have a deep neural network with a billion parameters, it's hard to say what is the reasoning of this thing besides giving like, here's all the weights. Right. That's all I got. Right. Right. And that doesn't help us. That's not how we understand things. And an explanation has to be tailored to a particular person's understanding. So what is an explanation? That's a philosophical question, right? And I don't think it's a real morass for the legal profession, if they're going to have a lawsuit and say, this algorithm has to explain itself. Well, what exactly does that mean? Let's get some expert witness philosophers in here to talk about the nature of explanation and epistemology and all. It's going to be a mess. I don't know how that's all going to to, play out. It's really interesting. But, they talk about AI taking away jobs, but I think it's going to create a lot of new jobs, because it's going to create a whole new area of law, of philosophy, of a kind of moral philosophy, of people assessing risks, that kind of thing.
I usually hear that argument made in the context of, I guess, software eats the world, and don't worry about it, we'll have more developers. But inevitably, of course, developer time is better leveraged than the tasks that it automates away, which is why it's like economically profitable. But in this case, I guess we really are discovering that like we have to do philosophy on a deadline. We have to really start ramping up our efforts. Are you optimistic, generally speaking? I mean, you're so steeped in the technical side of this, but on the human side, do you think that we're going to be able to adapt our society in time for a lot of these changes?
No, I mean, it's already shown that we can't.
Boy, I was hoping for something more optimistic.
No, we have not adapted our society, and we run into things like this whole epidemic of disinformation on social media, which has had real extreme real world consequences, and we haven't been able to adapt. And even the tech companies are trying to adapt. They're trying to regulate themselves. It turns out to be a lot more difficult than anybody imagined. Yeah. And technology alone is not going to solve the problem. We have to have, I think, policy and regulation, but that means educating a whole lot of people who are not tech people,
right,
into being able to understand what's going on in these fields. I just gave a guest lecture in a class at a law school of students who are, thinking about technology and the law, and realizing that this is just going to be an exploding area in the near future. So they have to know something about it.
Yeah. Every time I talk to anybody who's in AI policy, we've done a couple of those podcasts, and it just seems like this idea of like I think they call it the pacing problem, just the idea that the policy and regulation just struggles to keep pace with technology, especially when it rides these exponential curves. It just seems like people are wondering about, in many cases, pretty fundamental sort of redrawings of the line in terms of how systems work for policymaking, just to make them more responsive. Do you think something like that's going to happen? Like, are we going to have to iterate almost at a kind of startup pace on our laws, which sounds really scary to me as I say it, but is that something that you see happening?
I don't know, because it seems like laws and regulations go very, very slowly. You watch like these hearings in Congress about social media and algorithm bias and so on, and the lawmakers are just scratching their heads because they don't understand any of it. They don't have any idea
Very
how
comforting.
It works. So I can't imagine that the laws and the regulation can keep up with the technology.
So that being the case, it seems to put a lot of responsibility on the shoulders of researchers, since those seem to be the people best placed to actually do something about this. As a researcher, how has this thinking kind of affected your focus, like the sorts of things you've tried to draw attention to?
Well, for one thing, it makes me realize that my education as a technical person was almost completely lacking in this anything about the social impacts of technology. And that I think perhaps more quickly than the laws and regulations going to catch up, it's more like the technology education is going to try and put more emphasis on social impacts. And I see that happening like in computer science departments all over this country, at least, that ethics and social impacts are becoming part of the curriculum. People are starting to really focus on that. I don't know how helpful that's going to be. I think we'll see. But it's really important, at least for people to be aware of these issues.
Yeah, I guess as you said with law, I guess education moves slowly, kind of on generational time in some cases. Hopefully we'll be picking that up, and hopefully our AIs can help us learn faster. Oh boy, this becomes a whole thing. Well, Melanie, thanks so much. I really appreciate it. I really appreciate all your insights. I do want to recommend your book, by the way, especially for people who are listening to the podcast, who've been longtime listeners. We do talk a lot about the kind of AI risk side of things. If you want that other perspective, I really recommend going out and getting the book. It is called Artificial Intelligence: A Guide for Thinking Humans, and I guess, Melanie, it's available on your website.
They could find out where to get it. Yes, absolutely.
Okay, so we'll provide a link to that in the blog post. They'll come with the podcast as well. And Melanie, thanks so much again.
Thank you. It's been a great conversation.